Most of these string methods are quite straightforward. We've used a lot of them already. We've used count and index and join and find, replace, a strip. We've used a lot of these. Split. We've used lower and upper. These are pretty straightforward and they are Python native. I'd recommend that you run through these and actually use them. There's another point on regular expressions. Normally, if we get into anything with email addresses or maybe grammar parsing or natural language processing, regular expressions are going to become a really powerful and indispensable skill. But you can actually find a lot of your most common regular expression formats just by doing a quick Google search. If you want to find out how to validate an email, for example, there's a number of regular expression patterns that'll do that, but we can find that type of thing very easily online. But we're not going to get into that right now, as mentioned before. Let's talk about vectorizing string functions. Let's create a series with some strings in it. We can check for empties, just like we've checked for empties in other cases. One problem with empty string values is that if we try to run, for example, map on them, they'll just abort the operation. There are special filters that we can use that will contain that. So for example, we could use not null and run a map function that way. And we can also use methods like contains to set true based on more specific parameters. For example, here we're checking for only Gmail accounts. It returns those all as true. And of course, slicing works on strings as well. So what we mean is that we can get just the first 5 characters in a set of strings. And this is what we were talking about, that pandas allows us to perform element-wise operations on groups of data. Here's many other vectorized string methods, although we have already looked at a number of these and we'll see more of them moving forward. But it's nice to have a list of them here, and again, I'd recommend that you take some time and experiment with some of these. Now let's get into some tools and methodologies that we use for actually wrangling data. And the first thing we're going to do is take a closer look at this hierarchical indexing, which we talked about before. Here we're creating a set of 9 numbers, and we're creating a hierarchical index for those numbers. And so here's our 9 indices, and here is our 9 values. Let's run this. And it's worthwhile to take a moment and explore the grouping by pattern that's going on here. Even though we have 3 A's in here, it's only showing 1 A. It's created 3 values for that A index. Here we have 2 B's, so it's created 2 positions for that B index, and 2 C's and 2 D's. And you can see how that matches up here with the way that these numbers are organized. We can explore this hierarchical data frame. We can say go into the 0 index, B, and get into the 1 index, 3, and it's going to return this value. We can also use the slice here to grab anything from B inclusive to D inclusive and anything in between. So we're getting B, C, and D here. We can also use loc to get anything from the inner level. Let's run this. And we're getting the second element from A, the second element from C, and the second element from D. And of course we're not getting anything from B because there is no second index from B in the 0 index. Now, just so you're following the nomenclature, the first hierarchical index is the 0 hierarchy, and the second hierarchical index we call the 1 hierarchy. We can run an unstacked method on this. It'll convert it to a 2-dimensional data form. And again, by inspection, you can see that it's taken this second hierarchical index and turned that into our columns, while the first hierarchical index remains the row index. And we can reverse that with this stack method, which is the reciprocal operation of the unstack method.